Hello my friend, this is the chapter 3 of the KNX Basic Course, and it's about KNX TP topology or twisted pair topology. It's some interesting chapter from the book that we use it a lot during the projects. First of all, there are some abbreviation that you should notice before starting this chapter. As whenever you see the BC, it means backbone coupler, LC it means line coupler, DVC it means the bus devices, LR it means line repeater, PS/CH means power supply plus choke. And also for some examples you can see the brightness sensor in this chapter, and of course the routing counter that we will talk about it later. Okay, in introduction part you can see before 2019 each line consists of 4 line segments, and in each line segment you can have 64 devices. Okay, so when you want to create a line, you start with a first line segment, you fill it with 64 or less, and then you can add 3 other line segments by using the line repeater. After 2019, the new devices that have come to the market can install in a line, and there is no any need for line repeater anymore. Okay, so you can extend a line with 256 devices, okay, in one line segment. It means one line segment is equal to one line, and there is no need to any line repeater. Yeah, this is something important. But remember that if you want to see if your devices support this new feature, you should always check the datasheet of the device and make sure. So by default we assume that the device can be assigned in a 64 line segment, but maybe in datasheet says this is something new and we can apply for a new topology. Another important thing is this is for ETS5. In ETS6 we have a little change to include to add the wireless systems to each line, and of course we will wait. Now this is September 2021, and I think the new book will be released in January or February 2022, and then we will see what will be the differences. Okay, great. So this is a topology. Nowadays we face it. Each line consists of 256, of course the line coupler included. So without line coupler, each line can consist of 255 devices, from number 1 to number 255. And when you want to connect this line to another line, you use the line coupler. Okay? And when you want to connect the area to another area, you use the backbone coupler. Of course you can install or have the devices on the backbone line or main line. Yeah, so you can have the devices on backbone line and main line. But remember that for the previous devices, I mean before 2019, you cannot extend the line in a main line and backbone line. It means you cannot use the line repeater in main line and backbone line. Okay, so in before each line can have 255 devices, but the main line and backbone line only can consist of 64 devices. Nowadays all of them can have the 256 devices. Yeah. Okay, great. during these chapters you will see some terms like primary line and secondary line and what it means. You see this line that is here, that is in low section of the topology, means secondary line, okay? And these lines that is in higher level, it's primary line, okay? So remember this, you will see it later. The next part means line segment. So what we have in line segment, according to what I said, we are able to have 256 devices in each line segment that is equal to the line, okay, for a new devices. You can have the power supply units. Of course, you should have at least one power supply unit and maximum 2 power supply units, okay? And can you put these 2 power supply units right to each other? You should check the data sheet or ask the manufacturer. If there is no any mention, at least you should have 200 meters between 2 power supply units. And for some power supply units, for example the new one from the Siemens, you can put it right each other without any distance, so it won't be a problem. Yeah, so interesting. So what book written here, apart from the number of the devices that is possible to add in each line segment, that is 256, of course it's plus the line coupler is included, without line coupler is 255. It says, by means of telegrams, each devices can exchange information with any other device. Each line segment requires its own appropriate power supply. Each line segment should have their own power supply unit, okay? You cannot share the power supply between 2 lines. The actual number of devices per line segment depends on the power supply selected and the power required by individual devices. The bus cable can be branched at any place. Okay, so when you want to select the power supply, you should select between different category. So what is the difference? Okay, so here we have 160 milliamp power supply. We have 320 milliamp power supply. We have 640 milliamp power supply. We have 1280 milliamp power supply, okay? So these we should find the capacity of the power supply that we need for each line. So how we can consider that? Any device that you import in ETS like this, if you click on a device, from the right hand side in the information part in catalog, you can see the bus current. So this device consume 10 milliamp. So you can figure it out, the usage of the device from the ETS. Yeah, 10 milliamp. So if you have 10 devices in a line and each one consume 10 milliamp, it means 10 multiply 10, it's 100 milliamp. You need 100 milliamp, you can select 160 milliamp, okay? Also, there is another way to figure it out, the usage of the device. Now, for example, here I'm going to the website of the KNX manufacturer, Elsner Electronic. Then here in product, okay, for example, I want to see what energy, what is the consuming for KNX ETR 201 or 202 from the Elsner Electronic. I come to the device information in a website, and you can see the operating voltage is based on KNX, and the bus current is 25 milliamp. So it's not 10 milliamp anymore, it is 25 milliamp. Okay, So you should consider 25 milliamp for this device instead of 10 milliamp, and figure it out which power supply you need it. Yeah. So, and for example, if you want to choose these power supply units, always try to have at least 20 to 30% more power here. I mean, when you want to select, if you have 10 devices with each one consume 10 milliamp, you consider this one. If you have 10 devices, each one consider 20 milliamp, you consider this one. Okay? Always try to have 50, 100 milliamp as a reserve for future, and to have the safe planning. Yeah. Okay, so let's continue. The following structure type are allowed: star, line, and tree structure. As I told you before in chapter 1, the tree topology we can have it, but a ring structure is however not allowed. You cannot ring the KNX. A tree structure allows saving wiring material. Of course, in other protocols like, for example, LAN, you can have the ring, but here in KNX we do not allow to use the ring. And of course, you should consider that we never use the resistor in KNX topology. The smallest unit in KNX topology is a line segment. Nowadays, the line segment is equal to one line, so it's 256 devices in one line segment, include line repeat, line coupler. And in before, line segment is 60. It includes 64 devices. Yeah. Okay. So, in the next part, we are going to understand the area. Each line can connect to another line with the using of the line coupler. Okay, so you can connect 15 lines to each other at maximum and make the one area. Okay, so you put device 1 in a line 1 with power supply choke and extend it to 255 devices, plus line coupler is 256 devices, and then you connect it to another line and another line until 15 line with the line coupler. And you make one area. Each area has the main line. The main line has its own power supply unit. Why? Because the line coupler gets their power supplied from the primary line, the upside line, the north line, okay? And communicate with each line with the secondary line. So if you see the line coupler in real, there's two socket, KNX connector or KNX socket in the line coupler. Let's see it. Okay, so here, this is the line coupler from ABB. You can see there is two KNX connector. One is written behind it, next to it 1, and one is written 2. So the one is connected to the primary line and it should be powered by power supply units, and the second one is connected to each line in the secondary line. Okay, so this is the line coupler. Remember that as a hardware, there is no any difference between line coupler, backbone coupler, and line repeater. They are the same, but they are different in the application program and the physical address. Remember that. Okay, let's continue. Okay, now we get to the interesting picture of this chapter. So here you can see the maximum topology in KNX. Each area has the main line. The line coupler is connected from their primary side to the main line and from the secondary side to the secondary line, to each line in fact, okay? Maximum you can have the 15 line in each area. Then you can have maximum 15 area 1, 2, 3, 4, 5 until 15, okay? And you can connect each area with the backbone coupler. Backbone coupler also has two connector, KNX connector. The secondary connector is connected to the main line, and the primary connector is connected to the backbone line. Okay, and of course they should be power up. They power up with the power supply plus choke in a backbone line. So you need it to power these backbone couplers on. So this is the classical topology in KNX. The book said by dividing the KNX TP installation into lines and areas, the functional reliability is increased considerably. Yes, it is true. Of course, it increased the cost of the project, but the reliability will be increased, and the transparency of the project is much better. In this topology, the classical one, it is possible to more than 61,000 devices installed in a TP network. Of course, it's some theoretical and in real, because nowadays, for example, you have the 24 output actuators, you have the touch panel that can send hundreds of telegrams. So you should consider the traffic of the data. Yeah. Then we turn to the individual address. So what we can do with the individual address? You remember we have the area line device. So each device has the individual address with the 3 parts. You can see in a line 1, the device number 1, the individual address, it means it's written 1.1.1. It means this is the first device in line number 1 and in area number 1, okay? And this is the 255th device in line 1 and area 1, this power supply unit. There is no any physical address for that. For the line coupler in line 1, area 1, it's 110. So it is, because the third part is 0, it should be line coupler, then it is in line 1 and area 1. Same as here, this is the line coupler because the third part is 0. This is the 15th, it's in line 15 and area 1, okay? So, if the device is located in a main line area 1, it is written 1.0, for example, 20. Huh? So this is the 20 device in line 0. Line 0, it means this is located in a main line, and the 1 it's in a area 1. Okay. You can use these rule of thumbs in other areas also. For the backbone coupler, you can see this, it's written 1.0.0. It means this is the 0 device in 0 line with the area 1. So this is a backbone coupler always, huh? Until 15.00. And if your device is located in a backbone line, the first part is 0, so because it is not located in any area. The second part is 0 because it is not located in any line, and the third part, it's more than 0, for example 20. Huh? So 0020 means some device is located in a backbone line. So it is interesting. Always you can come to this picture and see this x.00, xx.0 or xx.1. These can show you how the coefficient can be changed according to the position in a topology. Yes. Good. So when the new device in S mode coming from the factory, or when you unload the device or do the reset factory, the physical address turn to 15.15.255. You can consider that also. Okay, the next part is going to define for you what the line coupler and backbone coupler or IP router do for the project or do in the system. They apply the filter table. And what is the filter table? We should be able to control the traffic of the data. Remember that in previous chapter I mentioned that when some bus devices wants to send a packet of data or telegram, all of the bus devices are listening. So it makes the bus busy. And if at the same time there would be lots of devices wants to send, it may face the system to the problem. So we should avoid this problem by using the filter table. The filter table is provided by line coupler, backbone coupler, and IP router. So the book said if a coupler is used in installation and the correct individual addresses are assigned to the corresponding couplers, I already mentioned about the individual address, a filter table will be automatically created in ETS according to your link between the sensor and actuator and controller in group addresses. The ETS provided the filter table, so it allows to route the telegram between the devices or between the lines and areas, and it blocks the rest of the telegrams with the destination of those group addresses. So anyway, the filter table is provided automatically by the ETS, and later you can see that we can add or delete it manually, of course, in ETS. Yeah. Okay. The coupler routes or it allows to transmit all received group addresses if these are listed in the filter table. In this way, each line works independently. So what it means? It means, for example, you have the building with 10 floors, okay? In first floor, there is some command to control the lights or to control the shutter or to control the HVAC system, okay? There is no need to send this telegram to floor number 2, 3, 4. There is no need. It should be blocked. But, for example, it is the hotel building, and for the admin of the system, it should be recognized the temperature of each room. So the temperature of each rooms, the data should be transmitted to the main line and backbone line and shows in admin PC or monitoring level for the hotel management. So some telegrams or data should be routed and some should be blocked. When we do not need it, should be blocked. Okay. The yellow LED on the coupler flicker when a telegram is received on the respective line, so we have something to show. The line repeater passes all telegrams. Notice that for the topology in B4 2019 that we use line repeater in each line to extend the line segments, the line repeater do not have filter table. Okay, so because of that, in a previous books, it was written that it is not recommended to use line repeater to extend. It is better to have another line with the line coupler because we care about the traffic of the data. Okay, each line coupler includes controller, microcontroller, ROM and RAM, and bus coupling units. Okay, it has two sides, primary side and secondary side. The coupler is designed for DIN rail. Nowadays, all of the couplers are installed in a DIN rail. For the line couplers, the primary line as well as the secondary line is connected via the standardized bus connector. Nowadays, of course, between two lines, there is an insulation of 1000 volts. It is for safety. It is a nice feature. The line coupler can be programmed both from primary as well as secondary. This is really important. Your USB interface or IP interface can be connected to the secondary line or primary line like main line and backbone line and program the device. These devices, line coupler and backbone coupler, only power up from the primary line, but it can be programmed by secondary line or primary line. Yeah. The coupler are equipped with a flash ROM memory. The coupler galvanically isolated the lines from each other. Okay, great. So it is mentioned about the physical address. Backbone coupler, line coupler, and line repeaters are identical devices. Their tasks depend on the location and corresponding assigned individual addresses. Okay, great. So this picture in a book provides us some very clear connection or wiring. This line 0, it means the main line. So in the main line you should have the power supply plus choke, and also you can have some devices like switch actuators or any other devices. Then you should connect this line 0 to the primary line of the line coupler of each line, okay? The first number 1 in this line coupler. And the secondary or number 2 of line coupler is connected to each line, line 1 or line 2 until line 15, okay? And of course in each line you can have the other devices, KNX devices. Now we are okay, so let's to have some example about the filter table and how it's created in the ETS. Interesting. So now we have the example. In this example there's 2 rooms, okay? In each room there is 3 lamps. So in room 1 there is a lamp L11, L12 and L13. These lamps represent the digital output of the relay actuator. There is one push button P1. And in the room number 2 there are another 3 lamps, L21, L22 and L23 with the push button number P2. And there is one sensor outside. It's a lux sensor, brightness sensor outside, that it's determine the amount of brightness in lux. And what is the operation? So the operation is this. If you press the push button P1, you can control these lights. And if the outside is cloudy and there would be no light or not so much enough light, the S1 sends the command to turn on the L11 and L21. So here you can see the group addresses. With the group address 0 to 11, the outside brightness sensors turn on the L11 and L21, okay? These lights that is near the window. And with push button P1 with the group address 5266, the L11 to L13 is turned on. And with push button P2, the L21 to L23 is turned on with 5266. The book is said, consider that there is no line and area, no specific topology. We do not use any line couplers. We put every devices right to each other in one line. So what's happening? In this project, if something's happen, if some command is coming from the push button or sensors, all the devices are listening, okay? So there is no any control of the traffic, and it's not something that we like in KNX. The book said maybe we can put the outside sensor in different line and connect all the devices in one line, okay? So here is the line coupler number 2 and this is line coupler number 1. So in line coupler number 1 we have the push buttons and all the relay actuators, and for sensors outside of the building we put it in line 2. Still we are in the same area, so we are in area number 1, but as you see there's 2 lines are used to represent this project. Okay, In continue of this project, the book is going to put the devices in different area and different line, and it wants to tell us how the ETS can create the filter table automatically. Look, there is one area. In area number 1 we have the line coupler 1 and line coupler 2. Okay, in line coupler 1 we connect all the actuators, relay actuators. Line coupler 2 we connect push buttons, and we have another area number 2 apart from area number 1, and in area number 2 we put the outside sensor. Okay, so now in this project we have two area number 1 and area number 2. We connect these two areas with the backbone coupler. Okay, and also in area number 1 we have two lines. So let's to see how we can represent it in ETS. It would be interesting. Okay, in ETS, as I said, we have two area number 1 and area number 2. Okay, so in each area, as you see, we should put the backbone coupler. So BC1 with the physical address 1.00 and BC2 with the physical address 2.00. That's it. Okay, then you can see in area number 1, okay, I put it like this to understand better. So you can see these two areas. I represent it in topology view. So here you can see that in area number 1 we have two line number 1. Okay, in line number 1 we have LC line coupler with the address of 110, and we have two push button. Okay, of course it means this one, push button P1 and P2, and in line number 2 here we have in fact line coupler number 2 and actuator. Okay, in actuator we have L11 until L23. So we can present the whole total of the project in ETS. And what's happening in group addresses? You can see in group addresses we have the group address 0 to 11 here as a central function because it's switch on off the two lights from outside, and in a floor number in floor number 1 we have 5 to 66 to control the lights and 5 to 67 to control the light for another room. So let's see, when we create this project and make the link in the group addresses, you can see these group addresses are filled with the group object of the devices. You can see if I come to the line coupler and press and right of the mouse and see the preview filter table. So you can see in line coupler there is a road there's a road for 0 to 11 and 5 to 66 and 5 to 67. So it's allowed. Why it is allowed? Because here if 0 to 11 it works, okay, I mean if the sensor, outside sensor, it works and wants to control, it sends the comments, sends the packet of data, telegram here. It should be routed for bus coupling, backbone coupler number 2, backbone coupler number 1 and line coupler 1. Okay, so 5 to 66, 5 to 67 and 0 to 11 is open here. Okay, it should be open. Of course, for 0 to 11 it should be open in backbone coupler number 2 and backbone coupler number 1. We can check it, no problem. Here, backbone coupler number 1, right click, yeah, this is allowed, and here also backbone coupler number 2, right click, yeah, here is also allowed. Interesting. And you can see that in backbone coupler number 1 and number 2, there is no destination group address in filter table like 5 to 66 and 5 to 67. Why? Because there is no link between the sensor and these group addresses. It's not needed. So when it's not needed, it's not here and it is polite. So what's happening? When you press push button P1, the packet of data is coming to line coupler number 2 here, and it's broadcast here because there exists with the destination address of 5 to 67, 5 to 67, because it exists in filter table here, it's routed, and this line coupler 1, it's executed. Why? Because it's these group addresses exist in a group address table of these devices. It exists coming here. Here is broadcast, and then these devices, if it's 66 or 67, execute the command and close or open the relay. Okay, so if I come to the line coupler 1 and line coupler 2, all the group addresses are routed. You can see, yeah, they are routed. Interesting. So I hope these examples can tell you that the ETS can provide the automatic filter table. So before I go to the routing counter, I want to mention you something more. It's interesting. Here you can see, if I click on this one, okay, for example, I add some group address here by hand, okay, some group address, for example, I add in central, yeah, in central here, I add some group address with the name test, okay. If I put test here, there is no link. So if I go to the backbone coupler, you see there is no mention of the new group address. I put it, it's not included here, or it's not included here, okay, because there is no any link between the group objects, so it's not participated in the how to say, the line coupler or backbone coupler. We can add it manually. We can drag it and drop it here in a line, and then see the filter table. Oh my God, it's coming. You can see the 020 is coming. Interesting, huh? And if you want to delete it, what should you do? You can click it on here, come to the right hand side, go to the information. If you want to delete it, you should press on line, okay? In the right hand side you can see, interesting, the 020 is here. You can select it for properties, information, and the table. Select it and click remove. That's it. Come to the line coupler again, do the preview filter table. You can see it's deleted. So you can add manually or remove manually from the filter table. After each change, remember, you should download it. You should download it, do the partial download to make sure that the new parameterization is coming to the system. Okay, the next concept is routing counter. Remember that I told you there is no possibility to make the ring in KNX. So if you do the ring by mistake, there is something to avoid serious problem. So whenever the telegram or the packet of data is past the line repeater or line coupler or backbone coupler, the routing counter decreases by 1. It started by 6, okay? So 6, 5, 4, 3, 2, 1, 0. That's it. If the telegram is with routing counter 0, it will not pass any line repeater, line coupler, and backbone coupler anymore. So the telegram with routing counter 0, it's not passed and it's blocked. Okay, so we eliminate to, or it's better to terminate the passing the telegram forever because of the ring topology by mistake. Yes. So you can see the routing counter in the group address in your ETS. The next concept is in KNX you can connect the gateway anywhere. But remember that it's better to connect the gateway or the monitoring system to the main line if you have one area, or backbone line if you have several areas. But why? You can see if I put the gateway here, and it wants to communicate with each line. For example, let me tell you, okay, I put, for example, I put the PC here, the monitoring system, okay? And if I want to communicate with each line, it is like this, okay? So there would be no problem for traffic of the data. For example, your monitoring system, it's coming here. But if you put the monitoring system here, what's happening? If you put the monitoring system, so it wants to communicate with each line, it's coming like this, it's coming like this, it's coming like this, it's coming like this, and here in this line coupler, we will face the problem. It's called bottleneck. So it's not allowed. I mean, we may lose the data and we don't like it. So put the monitoring system in mainline or backbone line. And if you want to have some gateway between whole of your system to another system, put it in mainline or backbone line. Maybe you have you would like to provide some communication between gateway to other protocol in this line 1 also. Okay, you can put it here. But if you want, for example, you have the building with 1,000 or 500, for example, the Hitachi split unit, and all of them has only one gateway to backnet. Okay, so you want to use the backnet to KNX. So you put the backnet to KNX to backbone line and or main line and communicate all the devices with that one. Yeah, it's interesting. I hope it would be help you. Then the book said, according to the physical of your project and the number of the devices you want to use, the safety or security concerns, you divide the buildings into areas and lines. So here in book, there is a sample. You can see on this building has a 5 floor and a west and east wing. Okay, so the buildings is divided to west as of area 1 and east as area 2, and each level each floor it's considered for each line. Okay, so there is some corresponding between the physical of the device, physical of the building, and the topology view. Okay. It really depends on your experience. So, first of all, the book said if we have 5 level, 5 floor, each floor should equipped with line coupler to connect to the main line, and the main line connect to the backbone coupler, and then you connect 2 wing of the building with the backbone coupler. Okay, this is a classical topology. Of course, instead of using the line coupler, we can use IP router. So how the IP router look like? Okay, the IP router, you can see here, the secondary side is KNX connector, and the primary side is the RJ45 that you should connect it to Cat5 or Cat6. Okay, so there is no any twisted pair for primary line anymore, and an upside or north of the topology will be based on IP. Okay, of course here there is a yellow and white for some IP routers, KNX connector, but it is only to supply more power for these devices, because in previous they need more power. After that the PoE type has came to the market, and nowadays it's a P-less. I mean, there's no need for extra power supply, and they can only use the power on a bus. Anyway, come back to their course. Here you can see we can replace the line coupler with IP router, okay, in different line and area, and have the KNX based on IP. It's so nice and recommended. Yeah, so you put KNX IP router, the physical address is like line coupler in each area, and then you have your line segments from 1 to 255. Okay, so with this type, the book said you can replace the upper side of the topology with IP, and there is no need for any backbone coupler or power supply in backbone line or power supply in main line. There's no need. Instead of each line coupler, you have the IP router with the same physical address of the line coupler. And of course the IP router provides you the full functionality of the filter table, and it can balance and control your traffic of the data in the system. Remember that for the small project to the middle-sized project, still the line coupler is recommended, and for the middle-sized project, big project, and very, very big project, it's better to use IP router. If you use the IP router, you should take care of the IP side in your building and always be in contact with the IT man of the building. It is so important to not let anyone penetrate the IP network. So, for more information about the IP, you can always check this company, Wenzel, from Germany. It provides you nice information. As you can see, there are some possibility of adding the IP. First of all, according to the recommendation of the book, you can replace all the line couplers with IP routers. That's it. And after the IP routers, you have the TP twisted pair, and above you have the LAN or the local area network with Cat6 or Cat5. Another option is, if you have an old project, you can only replace the backbone coupler with IP router to increase the speed on the backbone line. Okay, in this case the backbone line will be vanished or erased, and there would be no power supply for the backbone line, and only you replace the backbone coupler with IP router, and still you have the line coupler for your lines. Also, there is possibilities to combine these two parts, one area with backbone coupler as an IP router, and one area you do not have any line coupler and you use the IP router as a line coupler. So there is some combination of these devices. Thank you so much to listening to me for the chapter 3. I hope you learn a bit, and please let me know if you have any questions. Thanks.